All right, guys. So, where did we leave off last time? Last time we were here, we were able to get these LEDs over here lit. We had a couple hiccups along the way, but we don't want to light LEDs, right? We want to actually control a resistance ladder. So, I've thought about this for quite some time, and let's kind of draw this out. So, when we think about the wiring diagram for the audio controller, right? We have, in no particular order, right? Let's say volume plus, we have volume minus. We're going to have, let's say, fave plus, fave minus. We have our talk to speak. We have our hang up. And then finally we have our, source button, right? I believe that that's all 7 functions of the 2012 Camaro. So the way this works is we have our BCM here, and that BCM is supplying a 12 volt voltage, right? That comes in, and depending on if you press a button, it's going to, let's say, short this back to the ground. So I know that this is probably a little bit of a weird way of doing this, but let's kind of do something like this, right? We have here, and then we have it kind of like this, right? Here is each one of our switches, right? So we have 1, 2, 3. I could probably just bring it up on the screen, which would be easier, but each one of these resistance gets progressively higher. So, and again, these are not necessarily in the right order, so let's not worry about that right now. But if I were to press the source button and close this, that means I'm going to get 1, 2, 3, 4, 5, 6, all 7 resistors coming through. Okay? If I were to let it go, then we have no continuity. If I press hang up, then that allows it to go through. So how do we do this, right? Because this is a physical button. We don't want to use a physical button. The next logical step, though, is we want something that can control this switch, but digitally, right? Because remember, we are using the ESP82 to interpret our signal from the steering wheel. So what can we do? How can we actually address this? How can we, like, what is out there? What kind of electronic component allows us to utilize, let's say, a switch without actually physically changing it? Well, our favorite transistor. Okay, so transistors have kind of 3 prongs here. And again, I am not that good at these, so you'll get the best explanation I can. But you have a collector, a base, and an emitter. And what this does is it pretty much says, I have stuff going into the collector, and I want it to come out of the emitter only when I say so. And how does that happen? It's when I apply a voltage to my base. So that's sort of like having a kind of digital switch in here that when I apply a positive here, it's going to pull this switch down. It's a little bit more like how a relay works, but just bear with me. This switch will close and allow my information or my signal to flow across this switch. Now, I went through the process. I went through the steps of applying a, what's the right word? Individual transistors across here. It takes up a lot of room. And so we have something called a ULN 2003 IC. Okay? This UN 2003 IC is sort of like what I will call a, let's say, common cathode transistor array. Okay, I know that's a little bit complicated, and it's probably not even the right terminology, but how it basically works is you have an integrated chip. You have a leg here and a leg here. This is my ground. This is my common. We are not going to use this common, but then you have 1, 2, 3, 4, and I'm running out of room, 5, 6, 7. Okay, and on this side you have 1, 2, 3, 4, 5, 6, 7. And these all act as base for whatever you're doing, and these all act as collectors. All right? So as you can imagine looking at this, if I apply a voltage here, that allows this to connect and come out through the ground. If I apply a voltage here, and it doesn't have to be 12, so let's actually change that and let's just say voltage. Okay, then that allows this one to go down and go out through the ground. Okay, so this transistor array here is going to allow us to compress and condense what we're trying to do. And if we were to turn this kind of on its side here, then we can pretty much build this out, right? So at C7, let's say I have my BCM 12 volts coming this way, then what I can do is I can put my first resistor here, my second one here, my third one here. I'm going to try to do this so that they're in between. Okay? And then I can do something like this. So now if I were to press C, if I were to trigger a voltage on my base one here, right, through my ESP32, that's going to give me my BCM voltage traveling through all of these resistors and then connecting through to ground. And this won't go to ground. This is going to go this way to my BCM return. Okay? So now, again, we can see that by pressing, let's say, or applying a voltage to B7, which would be whatever the button is at the top of my resistance ladder, I get that single resistance to come through here and go out through the return. So I think this should work. And we're going to go ahead and test it out. So the only catch to this, guys, is that this only allows for this resistor array only allows for 4 transistor array. It only allows for 7 in this integrated chip. There may be larger ones that go beyond that. I don't know, but for the sake of our activity here, I mean, technically we only have 7 buttons that need to be interpreted on the in the 2012 Camaro, although there are 11 buttons. Remember, there's 11 buttons because we also have up, down, left, right, in addition to these 7 that we perhaps need to do something with. But let's test this out, right? So I'm going to set this aside. This is the explanation. And let's pull this over. So what you see here is my original common cathode LEDs. Remember, we had a little bit of a mishap last time. Here's all of our buttons coming in. Now over here to the right, I have our 2 transistor two transistor arrays. I have a single resistor coming out of the ground and going into our ground plane. I'm going to keep it simple for us. I'm not going to put an individual resistor on each of these. I think it's going to be too complex or too complicated. But all I'm going to do is I'm going to move some of these over and plug them into the side here. That would be the base as far as our buttons go. And that should allow us to control our individual LEDs. So let's pull these out, and I'm going to try to transplant them one at a time so that everything is consistent. So this is going to be our base here. Now remember, there's 7, so I technically need 8 on this one. Sorry, there's 7, so there's going to be 7 on this one and 4 on this one. So let's set this up with 1, 2, 3, 4. Okay, so we have this over here. And then let's move. I'm going to take this ground out for now. Now, none of this is plugged in right now. Let's be intelligent about how we do this. So, and then we have, let's see, we brought over 4, so we have 7 more to go. So let's take these out and let's bring these over. So we have 1. Now the order here doesn't really matter because again we're only doing testing. The order will matter once we get to actually programming this and putting the resistors into the right order and so on and so forth. All right, so what do we miss? We missed 1 on the final end, and that's our last one over here. So we're going to have to try to pull this over and see if we can get this in. All right, so now if you look closely, remember the bottom here is our common, or ground, sorry, our ground on this side. We don't plug anything into common on this side. Same thing with this second one. You'll notice there's a gap in between here. So we have our resistor going to our ground plane where our ground is. This is so my LEDs don't burn out when I test it. And then we have our 4 over here. And again, these are RGB common anodes, so we should be okay. So I'm going to pull this over. I'm just going to double check. I'm going to eyeball everything here and make sure that I don't have anything plugging into multiple power sources. And then what I'm going to do is I'm actually going to turn on, actually, I don't even have Arduino up, so I'm not even going to turn it on. I'm just going to keep you guys here with the setup. So if let me see if I can zoom out a bit here for you. Cool. All right, so now you guys see the steering wheel. We're going to test this out. Let's turn this light off so that we can see, make sure we're getting power to this from the ESP32. So we're first going to plug this in. Okay, I always keep this plugged in so I can see what my voltage is. So it's leveled out at 12.6. All right. Now we're going to take our ESP32. All right. We're going to plug this in. We should see our lights turn on over here. And they should stay on. And they are. Good, they're on. So now let's see if we get some lights lighting up. Oh, we have to plug our ground in. All right, so our ground is successfully in. We haven't burnt anything. So let's see. I'm going to come over. I'm going to press favorite up. Okay, we got a lot more lights than I expected. Let's favorite down. A lot more than I expected. So why am I getting multiple? Let's see, right. Yeah, we're getting a lot of bleed over. Why is that? All right, so it's been a couple days of me toying around with this, and what I learned is that we need to put the resistors ahead of these chips because otherwise it's not going to work the way we anticipate, which is okay, right? It doesn't change our strategy as far as actually executing this, but there are a couple things I have learned in the meantime. So let's first boot this guy up and make sure that what we have actually works. So first thing I'm going to do is I'm going to plug in my power source. Okay, I don't see anything because on my little display. Let's make sure that, oh, it's because I unplugged my power source the other day. Let's move this over a little bit so you can see it. My bench supply was unplugged, so let's get that plugged back in. Okay, so I know we got our 12.5, 12.6 volts coming in through our bench supply. I'm going to plug in our ESP32 over here. And ideally, what we will see is a different set of LEDs. So we have one here, 2, 3, 4. Now, remember last time we spoke, these were common cathode LEDs. When we were doing the testing directly from the ESP32. Now we're going with common anode because of how, I mean, I could go with individual LEDs, but it's going to just be easier to control everything separately using common anode. So let's pretend for the sake of this we have 12 individual LEDs. We only need 11. We only have 11 buttons on the steering wheel, but we should get a different light to light up with each button we press. So let's start with favorite up. Actually, hold on. Give me 1 second here. Is I'm going to get a sheet of paper. And what we're going to do is we're going to do 1, 2, 3, 4. RGB. RGB. RGB, RGB. So let's press favorite up, and favorite up we get 3 red. Favorite minus. So that demonstrates that our chips actually work to allow this pass through. So, you know, let's just do a quick test. I'm going to do favorite minus, hang up, and volume plus, and we should get a white here on red. So 1, 2, and so there we go. We're getting white. So the system can actually interpret those individual buttons being pressed separately very quickly enough. So we shouldn't see any sort of crossover between what we press here and it, you know, signaling a different button or a different thing. So that's where we're going to start. Now, again, I've thought about this over the last couple days. I think we're going to fast forward a little bit here because I don't want you guys to have to sit here and watch me redo a lot of this. But there's 2 things we want to do here, right? First and foremost is we know that on the Camaro, on the 2012, there's really no such thing as up, left, right, and down, right? Those don't exist in the 2012. It's really just these 7 buttons. So what we're actually going to do is we're going to map the left button to favorite minus. We're going to map right to favorite plus. We're going to map up to volume plus, and we're going to map down to volume minus. Okay? What is that going to do for us? Well, digitally, that's going to be real easy, right? In the code, we just change where we press down. We're going to have it change the pin for volume down. Okay? And where we have volume, we press the right button, we're going to have it initiate the pin for favorite plus. right? So once we set up our resistance ladder, then digitally we can reassign these buttons to kind of whatever we want them to be. The other benefit to this is if we look here, remember our array has the option for 7 buttons, right? We needed to use 2 of these because we have 11. Well, by doing this digital setup, if we go down to just these buttons, then we're actually in a position where we only have to use one of these arrays. We won't need 2. It's really important because it's going to free us up for what we're going to do with the cruise control. Okay, so we're going to go over this alt control thing, right? Repurposing our up, down, left, right buttons to actually behave differently based on what button's being pressed. So the first thing we want to do is we want to say bool alt control equals false. So this is basically saying when false, use original controls. Meaning if this Boolean alt control is false, then what we're going to do is we're going to allow these to operate as if they were up, down, left, right. So we've put our bool alt control. Now we want to actually use it, and we're going to come down here into this section where we're actually going to determine how we execute these buttons right here, right? So what I'm thinking is inside here we can say if alt control equals false, then we're going to do this. Okay? And what we can do is we can say else if alt control equals true, then we're going to do, we'll plug this back in here, and we will say, there's probably a much cleaner way of doing this, but I'm going to do it this. We're actually going to say when it's up, we're going to say change pin volume up. When it's down, pin volume down. When it's left, pin favorite down. And when it's right, pin favorite up. So you can see here, now I'm controlling these separately, right? When I have alt controls, my up button is going to do volume up. Okay, I think that's better. All right. Okay, much better. All right. So if we take this strategy and we do it this way, now what I'm going to do is in my code, I'm actually going to set my alt controls to true, and I'm going to load this in. Okay, now let's give this another shot. So this time, now that we have the alt controls enabled, what we should do is we should see up and volume up should do the same thing. So if I press volume up, I should get, volume up should give me 1 blue. Okay, and now up should give me 1 blue. Perfect. Now let's just test the rest. Volume down is 2 red. And down should be 2 red. Okay. Now let's test the last 2. Fave plus should be 3 red. Okay. Right should be 3 red, and then fave minus should be 1 red, and left should also be 1 red. So now we're digitally controlling the Now we're digitally controlling whether or not we have alt controls. This is good. This is exactly what we want. But here's the thing, okay? The disadvantage to this is that now we need to, every time we want to change from alt controls to not alt controls, we would actually have to come into the actual code and change that alt control. I don't want to do that. What if that means every time we do it, we're going to have to take the module out, bring it to a computer, or set up some sort of Wi-Fi. So what if we actually wanted to use some sort of a switch to change this? We want the ESP32 to detect whether or not we have a switch that's been set up or been modified. And that switch can be a physical one that we're going to flip and say, let's say, turn it on and off. Well, let's do that. Let's actually set that up. So let's go back to the screen here. And what we're going to do is we're going to say define pin alt switch. And we're going to set that as 23. Okay. Then what we're going to do is we're going to say, I don't want it to, because we're introducing now a physical thing, we don't just want to read the state. We want to compare, has it changed? Has something actually changed? So what we're going to do is we're going to say, give me the last switch state. And we are going to say, we're going to set that as high so that, remember, when this code first kicks off, when you start the car, my alt controls are going to be off by default. And then my last, because I want to detect whether or not it's changed, I'm going to actually set this to be high. So by default, it's off. Okay? So then what do we want to do? We want to set up, we're going to set up a function so that every time the loop processes, it checks, are we currently on alt controls or not? So let's do this. Let's create this function, void alt controls. And we're going to say the current state is equal to digital read pin alt switch. Okay? And so now we know the current state, and we're going to say if the current state is not equal to whatever the last state was, then we are going to wait 5 milliseconds. We're going to set the current state equal to the pin, right? We're going to set it again, just in case we we flip the switch and then flip it back off. And then we're going to say alt control is equal to current low, last switch state is equal to the current. And then finally, we're going to say serial print, alt control mode, serial print, alt control on off. Okay, so now this is going to basically say whenever whenever we detect that the state has changed, we are going to flip the alt control setup. And what do we want to do? We want to go into our loop, and the first thing we want to run in our loop is we want to check if we have alt controls enabled. So update alt controls. Okay, and the way this is going to work is it's basically going to detect every time you make a change to the pin, if whenever the pin is brought down, oh, you know what? There is one more thing we need to set up. We need to come into here and say, we need to change the pin mode for this particular pin. So let's just go here and say pin mode, pin alt switch, comma, and input pull up. Okay, so let's load this in and let's see what happens. Okay, so as of right now, we should not have alt controls enabled. So if I do volume, let's say volume up, I get one blue. And if I do up, I still get one blue. That is not what I was expecting. Damn. Going up as one. So, oh. So, guys, here's the issue. Okay, I put equals false here. It should be equals. All right, let's go back to the desk. Okay, now let's give this a shot. So now volume up, favorite up is lighting up red 3. Now if I press favorite up is right, I should get green. Good. So we have alt control. We have two different controls. But when I plug this in, now our controls should line up. So my favorite up is red. And if I press right, I also get red. Favorite down gives me this red one. Left should give me this red one. Okay, if I unplug this, now my alt controls are off. If I press favorite down, I get red. If I press left, I'm back to my original controls. So now what we're going to do once we start finishing up this design is we're going to have a little switch we can turn on and off that will allow us to initiate alternative controls for the D-pad whether or not we want them. All right, so this took a little bit of stumbling, some learning, some figuring it out, but now that we've done that, I can confidently say our code for our switches should be complete, at least for the audio. I don't think we have any other code we need to run or write for the audio. Next up will be cruise control, which is going to be a little bit more difficult, but I don't think it will be impossible. So we'll catch you in the next one. See ya.